Okay, what's going on? Today we're going to be reviewing, and it's a little bit of a long review. Okay, this is all about quadratic equations, x to the second power. So if I have x to the second power in a graph, that's going to make a U shape. Okay, so now that I know that it makes a U shape, we need three coordinates, with the most important being the middle, which is the vertex point in the equation. So xy, xy, xy. Okay, so to find the vertex here, what we want to do is label this A. There's no B because there's no x term. There's an x second power, then it goes right to the constant, so it's AC. So to find the vertex in an ABC, even though there's no B, I still think, okay, opposite of B divided by 2 times A. So if there's no B, the B is 0, and so is the opposite. 0 is opposite 0. There's no such thing as negative 0. Then 2 times A, 2 times 2, that's going to give me 4. 0 divided by 4 is 0. So that's your vertex. So if there's no B, your x vertex is 0. So then I take that 0 and I add and subtract 1. So 0 plus 1 is 1, 0 minus 1 is negative 1. So then we need to substitute those values in for x. So some of you could probably do this in your head. What's 1 to the second power? It's 1 times 1, which is 1, times 2 is 2, plus 3 is 5. Okay, so that's 5. And if you put 0 in, that's going to wipe that out, and you're just going to get 3. Because you times anything by 0, it's 0. It doesn't matter what power it's to. Then if I substitute the negative 1 in, it's going to be the same as when it was positive 1, which is why it makes a U, because 1 to the second and negative 1 to the second mean the same thing. Okay, so 1, 5. So this is x, this is y. So here's 1, 1, 2, 3, 4, 5. And then 0, 3. Please label that middle one. And then negative 1, 1, 2, 3, 4, 5. Okay, so the vertex is labeled, x, y. So x in the middle is 0, but you got higher and lower. So that means x is all, the domain's all. But the range is a different story. You put your y with your 3. Now the other y's I got were 5s. Well, 5 is great. If I put a 5 over that y, it'd eat the bigger number. Okay, so that's why you need greater than or equal to when it goes up, when it gets higher. Okay, y equals negative 3x to the second power plus 4. So again, it's another U. So I need to find the three coordinates with the middle being my vertex. Okay, so vertex, again, that's A, and this is C. So I'd go opposite of B divided by 2 times A. So I don't have a B, so the B would be 0 automatically. And then 2 times negative 3 is negative 6. So 0 divided by negative 6 is 0. So then I take 0 and I add and subtract 1. So 1 and negative 1. So then I substitute those in for x. So I get 1, and I put 0 in. I get 4. Then I put negative 1 in. I get 1, back to 1. Okay, so 1, 1. 1, 2, 3, 4. So now the vertex is up there. And then negative 1, 1. So please label the vertex. So again, your x is 0, but as you can see, you're both bigger than and smaller than 0. So that makes all. There's no greater than or less than. Now the y is 4, but then from there, okay, the 1s, those are less than 4. Okay, so it went down, so it'd be less than or equal to 4 on the range. Okay, whatever y is, y can be anything as long as 4 is bigger than y. It's 4. Okay, now in the next one, I see x to the second. You have an x to the first this time, but x to the second means it makes a U. So I go to that ABC. So there's three coordinates. And I find the middle by applying that same formula. This time the b will not be 0 though, obviously, because there's actually a b value of positive 12. So that would be negative 12, and then 2 times negative 3. That's negative 6. So I divide those, it's 2. So then I take 2 and I add and subtract 1. So 2 plus 1 is 3, 2 minus 1 is 1. Then I substitute those in for x. Plus 12, and then 3 plus 3, that's going to be 12. And I want 2 as my input, so now I replace the x's with 2's. Because y equals this, so I put 2 in, so that'd be 15. Then I put the 1 in. And that gives me back to 12, so I know I must be doing it right. Okay, so on the y-axis, x is fine by 1s, but the y's you have to go by 2's to get 15. 2, 4, 6, 8, 10, 12, 14, 16. So 3, 12. 3, 2, 4, 6, 8, 10, 12. Then 2, 15. 2, 4, 6, 8, 10, 12, 14, then 15. And then 1, 12. So 1, now I'm back to 12. Okay, so please label your vertex 2, 15. So I want you to look at that x value of 2, but you're bigger and smaller, so that's all. All the numbers are covered in the domain. But the range, you're at 15, but then you're smaller than 15. Okay, so 15 is bigger, so it has to eat the 15. It's got to be less than or equal to. Okay, then the last graph, we have x to the second minus 4x plus 5, so it's a u. So I need my 3 coordinates. And again, a has a 1 value, b is negative 4, c is 5. Okay, you put a 1 in front of the x. It's when the thing's not there where it's 0. So again, opposite of the b divided by 2 times a. So again, we have the b value negative 4. I just make it plus 4. And then 2 times 1 is going to be 2. 4 divided by 2 is 2. So you take the 2 and you add and subtract 1. So you're at 3 and 1. Now you replace the x's. So I take 1 times 3 to the second minus 4 times 3 plus 5. And y would equal 2 if I input 3. Y outputs 2. Now I put 2 in for the x's. So that's 1. And now I put 1 in. So that whole thing's 1 minus 4 plus 5. It's going to be back to 2. So 3, 2. 1, 2, 3, 1, 2. 2, 1. And then 1, 2. Please label the vertex. So 2, 1. So again, you're both bigger and less than 1. Than 2, I should say. So the domain is x equals all. Now the range, that's another story. You got 1, but then you're at 2 numbers. The 2 identical numbers are higher than 1, so it'd be greater than or equal. See, if I take this y and put 2 in there, if you're confused on what sign to put, just put y1 and pick one of these 2 y amounts. Let's pick 2, and you'd have to eat 2, wouldn't you? Yeah, you need the equals 2 line though. Okay, now let's solve some equations. Remember, we're thinking along 2 lines here. You can either use linear properties or factoring properties. So x to the second minus 2x minus 35 equals 0. So the x I'm solving for is to the second. It's also to the first, so you have to apply your factoring properties. So there's 2 answers. So on factoring properties, you need to have it equal to 0, which you do. And now you count the number of terms. There are 3, so it'd be GCF and then the T table. So I don't have x, I don't have the negative. 1, 2, and 35 would just be in the 1 row. And then 1 times negative 35 is negative 35, so it's a mismatch. It has to be a positive times a negative, and it has to add to a sum of negative 2. So 1 and 35, that's negative 34. That's way too wide. Then 35 divided by 2 is a decimal, 3 is a decimal, 4 is a decimal, 5 and 7. So if I add those, there's negative 2 right there. So your A is 1x to the second power. Positive 5, negative 7. Now x seconds, x times x. So then we put the 1 in front, and really I can't really divide those down. I mean, the only thing you could divide by is 1, but that's the identity property, meaning it just stays the same. Okay, so 1x plus 5 times 1x minus 7 equals 0. And then f1, f2. So 1x plus 5 could equal 0, or 1x minus 7 could equal 0. Okay, you don't need the multiplication by 1, just get rid of it. Then you'd subtract 5 and you get negative 5. Multiplication by 1 is worthless, just add 7 and x equals 7. Okay, x to the second minus 36 equals 0. So now I have x to the second only, okay? So that's not factoring properties, that's linear properties. So there's two answers. So linear properties, you're not doing any of that stuff. Only, okay? You got how many answers? You know there's two. Collect the x terms if you have more than one. Well, I don't have to collect anything because that's the only x I have. Now solve it. So there's no multiplication, just a second power and a minus 36. So we take out the minus 36 first with plus 36. Then you take out the second power with a square root. Okay, square root's always the last thing we're going to want to do. So x to the second power equals 36. Now I find the square root of 36 and it's 6. So it could be positive or negative 6. 6 and negative 6. Because we knew we were going to square root to get rid of the second power. Okay, next one's very similar. 4x to the second minus 36 equals 0. So I have x second only. So that will be applying linear properties, meaning get the x by itself with inverse operations. So there's two answers. And you have just a single x. You got a times 4 and a second power of minus 36. So circle the times. So you're going to plus 36 first. Then you're going to need to divide by the 4, and then you're going to cancel out the second power with a square root. So plus 36, and that's 36. Then you divide by 4, and that's 9. Now you find the square root of the number 9. What times itself is 9, and that's going to be 3. Okay? 3 or negative 3. So I got a couple quick ones there. Now, x to the second power minus 3x equals negative 20x. So when I look through the equation, we have x to the second and x. There's repeated x's, but we'll put those together eventually. So I now have to go back to factoring properties. So there'd be two answers. Okay, you need your 0 to do factoring properties, because before you count the terms, you need everything on one side. So I would add 20x. Now there's a nice x there for the 20 to go under. So it's going to be negative 3x plus 20x. So we have 0 and x to the second and x. And you can make a constant if you want. But we're going to have 1. And then negative 3 plus 20 is 17. But then we don't have a constant to put. So it's 0. So this only ends up with two terms. Okay. So it's a binomial. We go GCF and then check to see if we have a difference of perfect squares. X on the end, yep. Negative in front, nope. 1 and 17 is 1. So we divide by 1x. That's 1. X second divided by x leaves us with a remainder of x. And then 17, and then x over x cancels. Okay. Or no, shoot, what am I doing making a T-chart? It's GCF DOPS. I made the wrong box. Sorry about that. Okay, now I bring the 1x out here. And then you can cross that out. Now they're both positive, so they can't be a difference of perfect squares. It has to be positive, negative for you to even consider it as a DOPS, so it can't be. You write no. So then 1x plus 17 equals 0. So then 1x could equal 0, or 1x plus 17 could equal 0. Okay, multiplication by 1 is junk, so it's just 0. Again, multiplication by 1 we don't need. Subtract 17. And 0 minus 17 is negative 17. So negative 17 and 0. Okay, next problem. 3x to the second power minus 5x equals negative 3x to the second power plus 6. So again, I've got x second, I've got x, I've got another x second, but don't repeat it. We'll combine those, but these are different degrees that cannot be combined, so you have to use your factoring properties. So there's two answers. Okay, no 0. You got to have 0 to do factoring. So you add 3x to the second, and we would add that to the 3x to the second that's over there. And then minus 6. Now 6 is a constant, so it can't go with these, and it can't go with the negative 5x, so it is subtracted up in the hangout zone. So 0. So you have x second, x constant. So x second. Now, I'm going to say again, this is 6, but you do not add the exponents, okay? Changing the exponent is multiplication, division, okay? I'm adding. So when I add, I keep the exponent the same to the second power. And then negative 5x and then negative 6. Okay? Now you see the three terms, GCF table. Okay, I do not see x, I don't see the negative. 6 and 5, since 6 and 5 is just in 1's row, so we don't need 1. Okay. So 6 times negative 6 is negative 36, so that's a mismatch. That is a positive times a negative, and it has to add to negative 5. Okay, 1 and 36, that's negative 35. 36 divided by 2 is 18, that's negative 16, that's too wide. 36 divided by 3 is 12, that adds to negative 9, too wide. 36 divided by 4 is 9, and there's your negative 5 right on the money. Okay. Positive 4, negative 9. Now your A is 6x to the second, so you're going to have x times x, and then you place that 6 in front, and it's going to divide appropriately. So 6 and 4 are both in the second row, so we divide here by 2, and then 6 and 9 are both in the third row. Okay, so it's going to be 3x plus 2. And this is going to be 2x minus 3. Now look at your x's. 3x times 2x, 6x second. Now behind the x is 2 times negative 3 is negative 6, so it matches. So 3x plus 2 times 2x minus 3 equals 0. So F1, F2. So 3x plus 2 could equal 0, or 2x minus 3 could equal 0. So I would subtract 2, and that takes us to negative 2. Divide by 3. Now negative 2 divided by 3 comes out, I don't want that. Just put negative 2 over 3. Okay. Now, I don't care if you get a decimal, but not one of those ones that just go on forever. So 2 times x equals 3, divide by 2, and 3 divided by 2 is 1.5. I'm fine with the decimal, just not those ones that just go on forever. Okay, next one. X to the second power minus 9x plus 16 equals negative 4. So we've got x to the second and x to the first. So we again have to apply the factoring properties to solve. So there's two answers. I don't have my 0 like I need to factor. So I would add 4, and that goes nicely with 16. So we have the x to the second, the x, the constant, equals 0. So you have 1 as your x second, negative 9 as your x, and then 20. So now I clearly see there's 3 terms, so I would use GCF and the t-table. So no x, no negative, 1, 9, and 20 is 1. Then 1 times 20 is 20. It's positive, okay? So the factors I'm looking for have to match. They have to have identical signs. They have to add to negative 9, so they'll probably stay double negative. Now start dividing. 20 divided by 1 is 20. That's negative 21. That's too wide. 20 divided by 2 is 10. That's negative 12. That's too wide. 20 divided by 3 is a decimal. 20 divided by 4 is 5. So 4 and 5. That's negative 9. So A is 1x to the second. Okay, so it's x times x. So 1. So 1 and 4, that's 1. 1 and 5 is 1. So it's 1x minus 4, 1x minus 5. Okay, so those don't divide. 1x minus 4 times 1x minus 5 equals 0. So factor 1, factor 2. So 1x minus 4 could equal 0, 1x minus 5 could equal 0. So I don't need the 1 multiplier. You add 4 to both sides and you get 4. Okay, don't need the 1 multiplier, plus 5 to both sides and we get 5. So 4 and 5. Okay, next problem. X to the second power plus 6x minus 5 equals 0. So again, I have x second and x. We have to apply the factoring properties to solve it. So there are 2 answers. 0 is there. That's good. So 3 terms. So it'd be GCF table. So I don't see the x, I don't see the negative. 1, 6, and 5 is 1, so we don't need to go through with that. The AC product, 1 times negative 5 is negative 5, so it's got to be a positive times a negative. We're looking for 2 factors that multiply to negative 5, and they have to add to a sum of positive 6. 5 divided by 1 is 5. That's negative 4. No, you're not going to make that a positive 5 because then they'll match. They need to mismatch no matter what. So negative 4 is already too small, so that's QF. So X equals opposite of B, plus or minus the square root, B squared minus 4AC, B squared minus 4AC over 2A, over 2A. So the opposite of B is negative 6. B to the second, so 6 to the second, then A is 1, C is negative 5, then A on the bottom is 1. Okay, so we have negative 6 in front, 2 times 1 is 2, now I got to find the discriminant, that means the inside of the square root, so it'd be 6 to the second minus the product of 4, 1, and negative 5, and that's going to be 56. So positive or negative, and the square root of 56 is going to give me 7.48. Okay, now negative 6 plus 7.48, click equals, divide by 2, 0.74. And negative 6 minus 7.48, click equals, divide by 2, negative 6.74. Okay, 4x to the second power minus 8x equals 24. So we have 2 answers. Okay, and we have x second and x. So once again, factoring properties. So I don't have my 0. I subtract 24, but that can't go with this or this. So I put minus 24 on the end. Okay, so you have x second, x, and a constant. So you have 4. There's really nothing to combine. You just need to make sure you're putting the signs correctly. So that's a trinomial. So GCF and the t-table. So I don't see x, I don't see the negative, but 4, 8, and 24 is 4. Okay, so we need to factor out a 4, just not without x. So that takes us to 1. I'm not putting x under the line, so it stays x second, negative 2x, and negative 6. So I take this 4, even though it doesn't have an x, and just set it over there. Then ABC, 1 times negative 6 is negative 6, so that's a mismatch. Positive, negative. It's got to add to negative 2. So 1 and 6, that's negative 5, 2 wide. 6 divided by 2 is 3. That's negative 1. Now you're too narrow. Adding those got me negative 1. That's too narrow to ever come back to negative 2. It starts wide, it narrows, but if it goes too narrow and I haven't found it, I'm going to the quadratic formula with these values here. So cross that out, you won't need it. Opposite of B, plus or minus the square root, b squared minus 4ac, b squared minus 4ac over 2a, over 2a. So the opposite of b is positive 2, b to the second, negative 2, and then 4a is 1, c is negative 6, and then the a down below is 1. Okay, so I have a 2. 2 times 1 is 2. Now we find what the square root is. Okay. So negative 2 to the second, subtract the product of 4, 1, negative 6, and that's 28. Now you find the square root of 28. The square root of 28 is 5.29. Okay, so we take 2 plus 5.29, click equals, divide by 2, 3.65. Then 2 minus 5.29, click equals, divide by 2, negative 1.65. Okay, next one. 2x to the second power plus 7x equals negative 6. So again, I have x second with x, so again we have to apply our factoring properties. So 2 answers. You need the 0, so you're going to add 6, but that can't be added to the x squared or the x, so it's a hang-up. So you got x second, the x, and the constant. So you have 2, 7, and 6. So now you're at 0, and you see there's 3 terms, so back to the GCFT. So there'd be no x, there'd be no negative. 2, 7, and 6 would only be a 1, so we're not doing it. Okay, the AC product, 2 times 6 is 12, positive, so it's a match. And you have to add to positive 7 with the match, okay? So 12 divided by 1 is 12, that's negative 13, that's 13's wider than 7. 12 divided by 2 is 6, that's negative 8, but then just the number 8's wider than 7, so we keep going. 12 divided by 3 is 4, we add those, and that's negative 7. Okay, now you can stop. You're done. That's the right pair. You just got to make it positive 7 by making these both positives. See, now they still match. They just match as positives. Okay, but they have to match no matter what. So A is 2x to the second. So you put in your plus 3, your plus 4. Now we know we're going to go x times x with the x second. And then that 2 we're going to apply in front. And we have to have confidence that this is going to divide down. So 2 and 3 would just be a 1. 2 and 4 would be a 2. So this will just stay the same, 2x plus 3. And that becomes 1x plus 2. And see, look, 2 times 1 is 2, boom. 3 times 2 is 6, boom. So we got 2x plus 3 times 1x plus 2 equals 0. So F1, F2. So 2x plus 3 could equal 0, 1x plus 2 could equal 0. So subtract 3. 0 minus 3 is negative 3. Divide by 2, and that's negative 1.5. Okay. Now you don't need the multiplier of 1, you just subtract 2, and that's negative 2. Okay, I'm changing the next problem. Okay. I want you to put 3 and then a parentheses with x minus 5 to the second power plus 1 equals 19. Okay. So this is a little bit of a game changer. Now we have x with a minus 5 in parentheses and there's a second power. So the second power blocks you from being able to distribute. You can't distribute with that second power there, so you're going to replace that with h to the second power. Now x still has 2 answers. We still need to solve for x as 2 answers. So I set this up, I replace that with h. So you're going to have h with a times 3 to a second power and then a plus 1 equals 19. Now remember, h is not the end game. The end game is still the x. But I will bring back the x minus 5 over here. Now I bring it over twice because when I use my linear properties, I know I got a minus 1, and then I have to divide by 3, and then I have to take out the second power with the square root. Now the square root is where I get the positive and the negative. So minus 1, that takes you to 18. Then divide by 3. That's 6. Now find the square root of 6. It's not 3. What number times itself is 6? It's an irrational number. Okay? So it's 2.45. So you put 2.45, negative 2.45. So then you add 5 to both sides, and that is 7.45. Then you plus 5, negative 2.45 plus 5 is 2.55. Okay, couple story problems. An electronics store sells about 70 of a new model of digital camera per month at a price of $320 each. For each $20 decrease in price, about 5 more cameras per month are sold. Find how the store can maximize monthly revenue. So maximum revenue, you're finding a vertex. And again, the way you find the vertex, if you look at that graphing sheet that we've been looking at, is opposite of b divided by 2 times a. So we know that formula we're going to need. So if I know that's what I'm using, I'm just making a centered parabola. I don't need to do units analysis or any of that crap. Okay. So that has an xy coordinate, just like this one, and opposite of b divided by 2 times a is what finds that x. I don't care about these other 2 points. I'm only worried about this point here, the maximum. Okay. So now I need an equation. So I know that these parabolas have x to the second, they have x, they have constants that we have to look for anyway, equals y. So what's y stand for? Well, maximum revenue. So y is going to be our revenue. Now, revenue. It's taking the money I charge times the number of items that I sell. Okay. So it's like taking $2 for a box of popcorn, you sold 5 of them. 2 times 5 is 10. Now, I'm going to make a money items table so I can see what's going on more clearly. So we start at $320, we're selling 70 items. Okay. Now, we're decreasing by 20, and then every time I do that, we add 5 to the items. So 320 minus 20 is 300, and that's 75, and then that's 280, and that's 80, okay? Now multiply those if you want. You don't have to, but just to see what's going on. So 22,400. 300 times 75 is 22,500, so the revenue went up. So 280 times 80. Okay, now it's back down. So I'm guessing I change the price one time and I get $22,500. Now let's see if that's accurate using the way we've been doing it. So if I put a 320 and a 70, I'm minusing 20x here because I don't know how many times a 20. I think it's only once, but let's check it. Then plus 5x. Check the algebra. So I do the FOIL method. So I would take 320 times 70, then 320 times 5x, then negative 20x times 70, and then negative 20x times 5x. Okay, so 320 times 70, I got 22,400, which was the original revenue. And then this times this is x, it's going to be 1,600. And this is negative 1,400. That's x second. Negative 20 times 5 is negative 100. So the x second is negative 100. That's your A. Then I combine the x's. That combines to 200, and that's my B. And then 22,400 is my C, but I don't really need to label C. So the opposite of B is negative 200, and then 2 times negative 100 is negative 200. Now if I divide those, it's 1. Yup, you went one change, and then you maximize it. So it's one change in price. Now I'm guessing it's 22,500 when I put the 1 in. Okay. And then y is solo, so it's easy to solve for. You just plug the expression into the calculator. And you get 22,500, exactly like we said we were going to get. Okay, so the algebra just kind of verified that our table was right. So it's $22,500. Okay, last problem. Margaret is planting a rectangular garden. So we better make a rectangle. Its length is 4 feet less than twice its width. Its area is 170 square feet. Approximate the dimensions of the garden. So the area, I'm not building the border around the outside. Okay, I just put length, width, and then the area inside is 170 square feet. Okay, there'd be 170 little squares in that. Now we also know this can be represented with equals, and length is before it. Now I put W over here, and I put some operations with W. So twice, that's a times 2 operation. And then 4 feet less means minus 4. Okay, put it behind it. Now I set up my length width concoction here. Because the length, that's my equation, length times width is area. So the area we know is 170. Now, I want the same letter in each of these parentheses. Right now they're different, but that's where this comes into play. So length can be our base variable, and 2W minus 4 is replace. Okay? So take your L out, and you replace it with 2W minus 4. Since that's equal, we can replace it. And this can just go ahead and be W. So I use the FOIL procedure, but really it's not the full FOIL, it's just 2W times 1W, and then negative 4 times 1W. So that's 2W to the second and negative 4W. So you have W to the second and W. So 2, negative 4. You can't combine those. Okay, now we're solving for W. So we have W to the second and W. So we're using factoring properties. So there's 2 answers for W. I need my 0. I don't have it, so I subtract 170. So then W second, W, and the constant equals 0. So 2, negative 4, negative 170. So you can see there's 3 terms, so we have to do the GCF and the table. W, no negative. Now 2, 4, and 170. So 2 and 4 are together, then the table runs out. So you're going to run your divisibility test on the calculator with 2, okay? So 2 divided by 2, great. Negative 4 divided by 2, great. Negative 170 divided by 2, great. Okay, so they're all divisible by 2. Remember, as long as I don't get a decimal, that's what I'm checking for. And I use that when the table runs out. So that's 1, and then W to the second, negative 2W, and then negative 85. So you can take this GCF at 2 and do whatever you want with it. It doesn't have a variable, so it's really kind of useless. Okay, A times C, that's going to be negative 85, so that's a mismatch. Positive, negative. Now, you're adding to negative 2. So, 1 and 85, that's negative 84, that's too wide. 85 divided by 2 is a decimal. 3 is a decimal. 4 is a decimal. And you get 5 and 17. Now that adds to negative 12, that's too wide. Now here's the kicker. You get decimals all the way up until you divide by 17. But I already have 5 and 17, so that's a QF. I just did that to save time. This video is already long enough. Okay, so W equals opposite of B, plus or minus the square root. B squared, that's a QF. B squared minus 4AC, B squared minus 4AC over 2A, over 2A. So the opposite of the B is positive 2. And then B is negative 2. And 4AC, so A is 1 and C is negative 85. Now bottom, the A is 1. So we get rid of that, that's useless. It was useless anyway. So 2 times 1 on the bottom is 2. Now we figure out our discriminant. So you have negative 2 to the second minus the product of 4, 1, and negative 85, and I get 344. Now what's the square root of that? Guessing it's irrational because my table wouldn't work, so 18.55. So we take 2 plus 18.55, click equals, and divide by 2, 10.28. Then 2 minus 18.55, click equals, divide by 2, and you're at negative 8.28. Now the negatives is complete trash. It's useless. So my length and my width, 10.28 is the width, okay? Now the length, go up here and take the W out and put the answer you just got, 10.28. So I'll be taking 2 times 10.28, clicking equals, and then taking that product and subtracting 4, 16.56. That's your length. Those are down in the corner. Okay, see if you multiply these two. It comes to pretty close to 170.